listening to Electrician Live with your host, Paul Abernathy and Jay Grunberg.
All right, welcome to the Electrician Live. For those that are listening over on the podcast, you're wondering, where the hell was he? They're 12 minutes into the program and I forgot to hit the button. That is what wine during the day will do for you. Do not drink during the day, okay? It's the weekend. So anyway, so all those over there on the podcast, thanks for coming in. Tonight's topic is about paralleling and all the things about paralleling. I'll catch you up to speed. We're going to talk about all the characteristics of paralleling, when you would do it, why you would do it. Obviously, you're doing it because you need more ampacity, and conductors can only get so big, so we're going to break them up into multiple sets in order to be able to distribute the ampacity amongst multiple sets of conductors per phase. That brings you up to the point we're at this conversation right now, and it's easy for me to say after a bottle of wine, but hopefully after tonight's episode, you will understand paralleling a little bit better as well. So, Jay, sorry about that. Again,
no worries.
Okay, we're back up to speed.
They didn't miss much.
They didn't miss much. And at least I remembered it, right? Okay.
That's right.
All right,
sure.
So if you're at table 31016, ampacity table, for example, 1,000 kc mil is about the largest that manufacturers will go to. And you can get bigger, but not for general building wiring. So when you look at the ampacities for 1,000 kc mils, even under 90 degrees C, it's like 615 amps. So if I have a 2,000 amp service, there's absolutely no way that I'm going to be able to achieve that. So 6 and 6 is 12. Another one's 18. It's still, so that's, nobody's going to parallel it. That's 3 1,000s. Yeah. Nobody's going to do that. You couldn't get them in a raceway. It just wouldn't work. So typically we'll parallel that out into 5 or 6 sets of a 600 kc mil or a 500 kc mils or something like that sets, an engineer will design it out. But the reason we're doing that is I got one piece of switchgear and I'm going to bring in 6 or 7, depending on what it breaks out, the size you want to use. I'm going to bring in 6 sets or 5 sets or even 7 sets, depending on the size you want, of individual raceways that are going to come into this switchgear. And each one of these raceways is going to have an ABC neutral, ABC neutral, ABC neutral. So that's going to be evenly in each raceway. We're just talking generally right now, okay? Now, at each end, all of the A's will come together. All of the B's will come together. All of the C's will come together. So as I said at the beginning, for those on the podcast that missed it, that is no different than what we do with an individual conductor with the multiple strands, okay? They're all run in parallel, and they're all part of one conductor. So when we run parallel sets, we are required in the code to connect them at each end so that they're running parallel, but they act like a single conductor. And there's a reason that they have to be the same length, same characteristics, terminated in the same way. All these things that we'll look at tonight, simply because doing it differently could cause a current to be different in each one of the actual conductors. And by not dividing it out evenly, you could have too much end up being on one conductor based on whatever its ampere rating is, and it could exceed that, or it doesn't distribute it evenly, and that can create a problem. Okay, so you have to follow all of the characteristics when it comes to paralleling. Now, we talked about earlier, a lot of people in the residential world, for example, will have a 400 amp service, which is basically 400 amp 320 continuous, 400 amp non, which is the normal for residents. It's going to be non-continuous.
Sure.
In fact, the only things in a residence you do continuous load is only for branch circuits, and that would be any like baseboard heating or any water heater. But when it comes to the load calculations, when you're doing the overall load, that's just the branch circuit sizing. When you're doing load, then you don't treat anything as continuous in a dwelling. So that's why everybody always says it's a 400 amp service, even though it's a 320 continuous use type of meter, it's still 400. Sure. You put 200 amp panels, and typically they'll come out of the back of it with, they'll hit it with, most of them will do 4-aught aluminum. And they'll SCU, and they'll hit one panel and hit the other panel. That's not paralleling. Now, people think that, well, I've had people email me and say, isn't that paralleling? That is not paralleling because each one of those cables are not being connected together at both ends. They're at one end, but they're not at the other end. Okay?
Oh, okay.
So that cable is only handling that load in that panel. That cable is only handling the load in that panel. Okay?
Sure.
They might come back, but that's not paralleling. So what we want to do is we'll kind of look at some of the characteristics of paralleling. And, of course, I have the code book handy. Jay, you're not going to be able to see unless you're obviously watching monitoring it. Okay? You've got your code. It's good to go.
Got the code.
I'm going to switch to the browser version, and y'all will see me on the screen. I haven't figured out yet. I should have figured out how to get Jay on this screen. But I didn't.
My big old head, I'll take up that whole space. So
he would and the head would literally take up the entire space. There's no
right.
doubt about it. It would take it up. But anyway, let's see. There he is right there. Let me see if I can crop him down real quick. This is what's called editing on the fly, Jay.
Oh, hey, told you I'd take up the whole screen. Oh.
Yeah. So, all right,
fellas, don't ask what's in this cup.
Don't ask. No, it's not. Not tonight. All right, so here you see on the screen 310.10G, conductors and parallel. And so we're going to kind of look at tonight. And I've got my copy of my code book right here as well. It's a little easier to see. Some people say, well, I can't see the screen. Hopefully you got your code book. But we'll kind of look at it. First thing we look at is the general rules for 310.10G1. And, of course, I'll talk about some applications as we get into it a little more. And, Jay, if you have anything that comes up, just let her fly. And I'm going to also talk about some characteristic stuff that, while the code says a couple things, I will argue that it's, and I have a submittal for the 2023 to change some of these things in the code. But we'll argue that it's probably legacy information in the code and not 100% accurate in how things work. But we'll try to hopefully I've substantiated it enough that we'll get it taken care of in the 2023. All right, so conductors in parallel, let's kind of look at it. 310.10G1 general says aluminum, copper clad aluminum, or copper conductors for each phase, polarity, neutral, or grounded circuit shall be permitted to be connected in parallel, electrically joined at both ends. So that's kind of what I was talking about earlier, Jay. The only way that it can constitute a parallel application is if it is physically connected at both ends.
Oh.
So I could have 5 different raceways with black, red, blue in each raceway with a neutral. And the only way it could be parallel is if all the blacks were together at the end, all the blues were together at the end, and everything comes together at the end, right? That's the only way it would work. Separate blacks, separate blues, separate reds, and they go to their own terminals, okay? And it might be a lug that's got, 5 lugs on it, or, to handle 5 separate conductors. But once it does at each end, then those 5 reds, for example, replicate a single conductor. Even though they're parallel, they act as a single conductor. That's why we can take the ampacity for each one and add them up. And that's what's going to give us our total, let's say, of the 2,000 amps. Okay? That's how we would do it.
What if the conductors added up together would be more than 2,000 amps? You
can always have more, but when you're over 800 amps, for example, when that case scenario is you can't use next size up rules, so whatever you overcurrent, if it's 2,000 amp overcurrent device, then I'm going to have conductors that handle at least 2,000 amps. So if it's 2,100 or 2,200, that's fine. It just handles more. In fact, you might be necessary because you might have something that you might worry about like voltage drop or something. And things like that you might affect something, So at the end of the day, if it's 2,000 amps service or switchgear, I'm going to have 2,000 amps worth of wire, put it that way. Okay? So it might be 600s. I don't know, add it up. I don't know what that would be. But I can't remember what 600s are. I don't know if it's
you're talking about the actual wire size 600.
Yeah, if it's 600s or
So would it be 420 then if we're using the 75?
Yeah, for 75, obviously we can do adjustment and corrections. We can use a 90 for adjustment and corrections, although we can't exceed the value of the 75. So it's so much easier. I tell people just to do the 75 and select your conductors based on the terminal limitations first. Then you can do adjustment and corrections to see if you still have a conductor that can handle the ampacity. But always select your conductor based on your terminal limitations. So 420, how many of those did you need for 2,000?
I think we need 5 of them.
Divided by 420? Yeah, 4.76, so you need 5. So you'd have to have 5 600 kc mills copper to achieve the 2,000. And so you would have 5 sets to achieve it.
So with these parallel raceways that you're running underground, because like you said in the beginning,
or above ground, could be running through the middle of a building or something. Could be 5 sets of a feeder to a remote distribution panel or something like that.
When you're running these 5 sets, you would have to think that wouldn't the electrical engineer for the drawings give you these, and if they do, are they ever wrong, or is it the electrician's responsibility to double check them? Because again, if you're running 6 parallel runs of 600s and you're supposed to run or 5 in this instance, and you have it installed, but you're supposed to run 6 or you didn't run enough.
Yeah. So again, most of the times when you're dealing like this, they're going to be engineered drawings. But I'm going to tell you, like I tell electricians all the time, and like I would tell you, and I would tell your company if you were doing it, I always check behind the engineer. I mean, our job as electricians, as a skilled professional, is to have the knowledge, the understanding to be able to second guess somebody and double check, right? Just double check to make sure that everything looks right. And it doesn't take much to look at and say, 5 sets. And find out what the ampacity is, do it times 5, and see if that's going to be adequate, right?
Sure.
But we got to do it. But usually you're right. The engineers should do this for you. We hope that they're the ones that figured it all out for us already. But and then of course it's got to go through plan review, right? And you hope that they catch it as well. Then not every plan review is good, so I mean you gotta, and a lot of them just stamp it. When the engineer stamps it, they stamp it and let it go. So just got to be aware of that. Okay. Now notice, what you will notice here is that it didn't say anything here about equipment grounds. Okay. Yeah. Didn't make any statement for that in this part of it. It's talking about neutrals or grounded conductors, because you always have a grounded conductor when one of the phases is intentionally grounded. But you don't always have a neutral, which is equal balance from any conductor that's measured to the neutral point. Okay, so in that case, all of these can be run in parallel, except for an equipment ground. Okay, well, of course we'll talk about that in 250-122 when we get there in a few minutes. It also states that one thing that you do in paralleling is that the sizing has to be 1/0 and larger. Okay, so 1/0 and larger is your threshold. Now, there is exceptions to this rule, and that is for some unique applications that we're not going to go in tonight because it is very unique and typically not for the building wiring aspect of it. So typically in paralleling applications, 1/0 and larger is going to be what we would utilize for a paralleling application, okay? Now, engineers have some ability under engineering supervision, and that's anytime you might see paralleling done that is less than 1/0. I would look, if I was the electrician and you saw it, and in your mind you're thinking, I know paralleling has to be 1/0 and larger, and I see something that's smaller, then make sure you check with the engineer, okay? See if it's something they haven't done or something like that, okay? That's something that they're going to be aware of.
So there's a question from Elwood on here. He says, how many overcurrent protection devices? So if you're running, I think what he's saying is if you're running your parallel feeder or your parallel conductors, are you allowed to hit multiple overcurrent devices, or is this just for one?
So paralleling, again, you have to bring the conductors together at each end. So it would be for one overcurrent device that you'd be paralleling. Okay? So we're not talking taps. We're talking if I have a 2,000 amp device, overcurrent device, I have to, all the black, red, blues, all the blacks have to come together, all the reds have to come together, and all the blues have to come together at the same terminal. So it would be kind of hard to split that off. Okay.
So would that terminal be? I guess what I'm thinking is like maybe a utility side transformer.
So you can have
You
could have it come from a utility, and they'll bring in sets that'll come to your switchgear. But you could also have, let's say I have a really big building that has 2,000 amp service, but let's say I have 1,000 amp remote distribution equipment downstream somewhere.
Oh, sure.
I mean, who wants to run, who wants to run two 900s?
What is that?
I mean, who wants to do that? So most of the time, it's going to be like even a 1,000 is going to be broken down into 4 sets of, I don't know, like 300s or 350s or something. Right?
Yeah,
and so
sure.
That's paralleling. You can't deviate from that. It wouldn't be paralleling. So if I took one end and they were all together and then I got to the other end and it's split up, that wouldn't be paralleling. Okay? They has to be together at each end. All right? You with me?
Makes sense. Yeah, it makes sense.
Okay.
You're saying instead of one large conductor
just
that would
multiple
feed
small
that
ones.
200 amp service,
2,000
you'd break it down, or 2,000 amp, you'd break it down to multiple conductors in a parallel run that would eventually be the same size or larger or handle the same amount of ampacity.
And that's what you're really doing. And I tell people when they think of paralleling is start from lugs A all the way to the other end, and I say I'm running 5 of them. They're running them together. They all have to be the same length. Same characteristics. We'll look at that in a minute, obviously. Have to have the same insulation type. They have to be terminated the same way. Everything has got to be basically, if you think about it this way, as I said earlier, a single conductor, say 500 kc mil, has all those strands in it, right?
Yep.
Paralleling is the same thing on a grander scale. It's just each conductor act like it's a strand. And so you're bringing them all together, and it's with one big conductor. So you're getting the benefit of each individual conductor brought together to replicate one larger single conductor. With me? So it really is the only way you can do it and be able to run something to these large services. This is the only way you can do it is paralleling. There's no other way. You have to be able to parallel. Now, with that said, we have conductor and installation characteristics that we have to be very aware of. And this is where I get a lot of pictures from people, and they are all kind of wonky in different things. And this is where you got to be very careful. And I tell people, when you cut your wire, cut them all the same length. And cut it for the maximum length that you need. Because you can loop slack or you can keep some slack, but they all have to be the same length. So if you look at the characteristics, let's look at 310.10G2. And again, for those out there, we're in the 2020. And I will promise you something. I said something to Jay before we started tonight. I said, Jay, I have to be very careful that I do not fall back into Electrician Live being Paul talking about code all the time. So you're gonna give me a break tonight, but Jay's gonna pistol whip me back to more interesting topics than code. Although I've got my code freaks out there who love code, but again, bear with me tonight, okay? And I've been drinking wine all day. Did I tell you that, Jay? I'm sorry. I did tell you that. All right, sorry. So 310.10G2 turning into a wino. All right, it says the paralleled conductors in each phase, polarity, neutral, grounded circuit conductor. Now, check us out. Equipment grounded conductor or equipment bonding jumper shall comply with all of the following. Now, this is real interesting, and this is the genesis of one of my submittals for 2023's change. We had the rules for paralleling. It said what we could parallel, right? I mean, it gave us the rules here, the general rules for paralleling. Then down here it mentions equipment grounding conductors and equipment bonding jumpers. Okay, are you ready, Jay? You ready for my first soapbox moment?
I'm holding tight.
All right. Give
it to me.
The equipment grounding conductors are not permitted to be parallel. They have to be full size in each raceway. Why that's even here makes no sense, because we do not have to parallel equipment grounding conductors in order to take the benefit like we do with phase conductors, trying to get more current. We're not. The code requires in 251.22 for equipment grounds to be full size. Now Jay's playing with his background. Y'all didn't see that? I see that. He's just playing around back there. All right, so for me, sizing the equipment grounding conductor does not, the need for it to meet these characteristics is kind of foolish, all right, when it comes, because each one of the equipment grounds are required to be full-sized anyway. You're not getting any benefit of paralleling them. Now,
so when you have the 2,000 amp service,
and the equipment ground, I'll let you go with your thought, then I'll keep going.
Well, what I was saying, what we went over was, if you have a 2,000 amp service and you're running 5 sets of 600s, then your grounding or your equipment grounding for those, you're saying I wouldn't be able to cut my equipment grounding down into fifths or whatnot. Like I'm not cutting it down.
No, so if you look at 250.122, it tells you the minimum size equipment grounding conductor is based on the size of the overcurrent device. Period.
Oh,
This is a 2,000 amp service. 2,000 amp service requires a minimum of a 250 kc mil. And it requires it to be in each raceway.
In each raceway. Now, if it's required to be full size, then why do these characteristics even matter for an equipment grounding conductor? It's got to be full size anyway. See, the reason we're paralleling is to get the benefit of more ampacity. That's the main reason. You said it right off the bat. That's the main reason we do it. With lower size wires.
Smaller wires.
Smaller conduit.
Easier to handle, easier to function with, easier to install. That's why we're doing it. And the reason we're keeping all those characteristics the same is because current needs to divide evenly on all those different parallel sets. It's nothing to do with the equipment grounding conductor. To me, it shouldn't even be here. It shouldn't be in 310.10G2. Okay, if we already going to say that it needs to be full size anyway, if that's the case, why don't you let me parallel the equipment ground then, smarty pants, up in the code panel? Wait a minute, I'm on the code panel. Never mind. So, you're gonna let me parallel the neutral, right? I can parallel neutrals divided amongst 5 raceways, but you won't let me parallel the equipment ground. Why? Because we believe that if you have a fault in any one of those raceways, that the conductor has to be large enough to be able to carry that fault current to be able to clear that 2,000 amp overcurrent device. That's why we size equipment grounds. And we have data that supports that for years and eons. We don't know where it all came from, and we can't find the test data, but we know that for history, 251.22's worked out okay, right? Breakers do trip. I mean, we know that that's pretty solid. That table's pretty solid, okay? So, at the end of the day, what's the point in paralleling if you can't parallel the equipment grounds down? You can't use them as a cumulative like you can the phase conductors, like you can the grounded neutral conductor. You can't do that with equipment grounds. So why do the characteristics even freaking matter when it comes to an equipment ground? So anyway, we're going to go with the premise that it is here. And I'm just kind of explaining that to people so they can get the logic of why I'm putting in a code proposal in 2023 for this. So anyway, and you'll see what I'm talking about. So let's look at it here. Number 1. So let's talk it and keep it in terms that we can understand. Phase conductors, A, B, C. Simple stuff. Got to be the same length. If it's a 150-foot run and I've got 5 sets, remember, the radial bend of the outside raceway, the lengths are going to be different than the interior raceway.
Right.
So if I'm going to have an A, B, and C in this one, A, B, C in the second one, A, B, C in the third one, A, B, C in the fourth one, A, B, C in the fifth one, got to be careful because the A phase in the fifth raceway is going to be longer than the one in the first raceway. Yes. However, when I'm cutting them, I tell people all the time, cut your lengths as if they all were based on the longest raceway. And then they go, well, what do I do with the extra in the box? Well, you're going to have to either, position it out. But again, it should be enough room for you to take that make up that extra distance. But you can't cut that one shorter than the other because the current that's going to be on the conductors are going to be different. Why? Because there's more resistance, because there's more copper on the longer one than it would be on the shorter one. So the current's going to be different. And so it's not going to divide evenly. So again, and I do a whole podcast on that, or video that I did on understanding the lengths and the math behind it and how the ampacities change. We won't go into tonight's episode, but it does change. And this says that they have to be the same length. So that's cut and dry, right? So that means that even the shortest run, the conductors have to be as long as the longest run. Okay?
Sure. I got a question for you, and I think Joel has the same question. Okay. And he says, can black, red, blue, white, so pretty much your three-phase conductors and your grounded conductor be in different raceways? What I think he's saying is, can you put all five blacks, all
separate
five
them out
phase in one raceway?
So you mean
and
separate
then
them
all
out?
Red in another raceway, all blue in another raceway, all whites. So you're having five conductors or of the same phase coming up into that panel or what that cabinet to hit that terminal. Could you do that?
Well, there is an allowance for you to be able to do that, whereas you actually can put separate the A's, the B's, and C's. But that is a very unique application, underground application, and typically it is very, very not typically done that way because you create magnetic fields and it makes it harder for the application. There is a rule that allows you to do that, but I don't want to go there tonight because we don't have enough time. But who asked that? Joel?
Joel did, yeah. Which would make sense, though, because then if you did come into one raceway with all your A's, you would just cut them all at the same length because they would all go to that same termination block. But,
right. Well, the problem with that ends up running is that you create magnetic fields and problems because you don't have cancellations. You don't have A, B, and C, so you create a lot more impedance, and it causes a problem. But there is an allowance in the code for you to be able to do that, but it is underground applications only, and again, it's typically not talked about. So we want to keep it without causing too much confusion tonight because of the time frame we have on a 1 hour show. But I've written it down. You said it was Joel?
Joel.
Okay. I have written it down because I think that would warrant me doing a separate a video that actually shows the different characteristics to be able to do that. Because I don't think that we could, mainly the easiest thing to remember is you're not going to be able to do it. So here's the easy way to think about it. Where this usually gets done inside of a building when you're running separate sets, you could not do it that way inside a building above ground applications where I can run all A in one, all B in the other, and all C in the other, separate them like that. It is a very unique application. Typically, you're going to run ABC and neutral in one, ABC and neutral in the second, ABC and neutral. That's the traditional way we do it. Then you don't have an issue of inductive heating. You don't have the addition of magnetic fields, increased impedance that takes place. It's just an easier way to do it. But you end up with that situation where you're going to have a conductor on the inner raceway that's going to be shorter than the one on the outer raceway.
That's right.
But you're not above ground going to be able to solve that, Joel, by simply putting all the A's in one, all the B's in. But I think rather than talk about it, I want to save that for a separate episode. Otherwise, it'll take us down that hole. Just say that that's a unique application, underground application, and it's very unique in the raceway types. So let's keep it. We'll keep that one for that. I'll promise you I'll do an episode on that. All right, so keeping the lengths. That's important. Keeping the lengths the same. Number 2, have to consist of the same conductor material. Okay, sure. Now that is per your phase. So all the A's could be copper, all the B's could be aluminum, all the C's could be copper. But all the B's that are aluminum, all the B's have to be aluminum. Okay, and of course they're going to be a bigger sized, right? So that becomes a problem. But when it comes to consistent conductor material, I could have phase A's, phase B's, and C's. And remember, this is per phase. So all the A's could be copper, and whatever they might be, 600 kc mil, whatever. All B's can be aluminum, and they all might be 750 kc mil. Crazy install, but could do that. And then C could be all copper again. And it would be, okay, so that is possible because we're treating these per the phase, okay? So got to be the same conductor material. Next, be the same size and circular mill area. Again, that is per phase. So all of the A's could be a 500 kc mil, all the B's could be a 750 aluminum, for example, and all C's could be 500 again. So again, it's per phase that the characteristics have to be the same, okay? Next, have the same insulation type. Again, that's each phase has to be the same insulation type. So I get that asked me quite a lot. I could have THHN, THWN on phase A. I could have X on phase B. And I could have THHN on phase C, as long as the characteristics of that phase are the same. And then lastly, be terminated in the same manner. Now, that means it's terminated, if it's terminated into a lug, that each one of them are terminated in the same type of lug, the same location, torqued at the same value. But again, everything done in the same manner. Then if you do that, then you're okay. Everything's fine, and you're doing it. Now, here's what people say to me all the time then. So what about that equipment grounding conductor? Because I have some images. Actually, I did a graphic that I sent in with my public input that shows 3 sets or 5 sets or whatever it was. The equipment grounds was terminated, identical on 3 of them. And then the 4th one went over to a separate lug that was bolted onto the enclosure. And everybody was like, people that I talked to joking with them, they go, no, it's not terminated in the same characteristics in the same way. And I said, well, yeah, it does, but the problem is it does say equipment grounding conductor and equipment bonding conductor up here. But why does it have to be terminated the same? So my manner is terminated in the same manner is that if it's in a lug and the lug is connected to the enclosure that is bonded, and then you have the other lugs that are all together, so you might have 4 lugs that are together for the other 4, say it's 5 sets. And so I've got 4 of the equipment grounds on a lug, and then I got the 5th one over on a lug that's identical to those, but is instead drill and tapped to the metal enclosure. What's the difference? Well, some would say, well, it's not terminated in the same manner. Sure it is. It's terminated in a lug, same type of lug. It's just not at the same location. And people go, well, that's not how I interpret it. It's got to be interpreted in the same manner. It is in the same manner. Same type of lug, same torque, same bonded enclosure. What's the difference? And then I ask them, what are you paralleling an equipment ground for? And I have a very knowledgeable friend of mine says, well, you're paralleling it out because in a fault condition, it divides. No, it doesn't. If it did that, then we would be having the raceways equipment ground. I'd be able to parallel them and use them as a set. But I can't. I've got to have full size in each. So any one of those equipment grounds can handle the fault current to clear that 2,000 amp device because that's what the code tells me. This has to change. This has to change because it should not be that the equipment grounding conductor or the equipment bonding has to, because you're not paralleling those. Now, theoretically, you're paralleling them because you're putting one in each raceway. But you're not paralleling it for the
Right.
same reasons that we parallel phase conductors, that we parallel grounded conductors, right?
Right.
And in fact, it doesn't even tell us in 310.10G1, it doesn't even list equipment grounded conductors. And that's a general rule.
Yeah.
So it's just, we have to clear that up. And in fact, I know so much that I actually sent an email out to a very knowledgeable individual who's on the NEC Technical Correlating Committee and also very high up in one of the major associations of labor for electricians in the country, who is very well known, good friend of mine, great guy, will not name drop. He agreed and said it needs to change. So hopefully when he sees it as a public input, and of course I'm not on this code panel, but I would love the opportunity to explain to them, we're not paralleling. If you're going to make me do this, then let me parallel the equipment grounded conductor. Let me get the parallel benefits. Why do I got to run it to full size? But of course, I'm also on Code Making Panel 5, and I'm going to tell you, yeah, we like it being full size. So at the end of the day, they just need to remove equipment grounded conductor.
Yeah,
equipment
move that
block frame.
wording out of there.
It's not necessary for this part of it because
I see it.
you're not paralleling them for any benefit under 310.10 at all.
No, you're just putting them in there because each raceway requires it.
Yeah.
They require that equipment grounded conductor, and that is what it is.
And we know this. We know this also, Jay. Real quick, if you jump down,
Yeah, of course.
If you jump down to 310.10G5, equipment grounded conductors, it says where parallel equipment grounded conductors are used. Okay, now that is not paralleling it to get the benefit of anything. They're running side by side, so they're paralleling. It says they shall be sized in accordance with 250.122. But 250.122 requires them to be full size in each raceway. So, what's the point? Okay. Anyway.
Well, they are paralleled, but they're not. We're not, like you said, we're not getting the benefit of derating or cutting down the ampacity.
Yeah, why be 250? Why be 250 kc mil in each raceway if I could parallel? Heck, let me parallel that. If it says that it has to be 250 under 250.122 for 2,000 amp service or 2,000 amp overcurrent device, then okay, let me take that 250,000 and divide it by 5 sets. And of course, the code says paralleling can't be smaller than 1 aught. Of course, it didn't list equipment grounds up there when it said that. All right, so let me put a 1 aught in each raceway instead of a 250, and then I can use them together cumulatively. The only problem with that is, like I said from the beginning, if I have a fault inside of one of those raceways, a fault to ground, then I need to be able to clear the overcurrent device. Now,
I got what you're saying. So you're not mad that they're not allowing you to use the benefit of the parallel to decrease your equipment sizing conductor or equipment grounded conductor. You're just saying that in this article, this section, that they need to remove that out because it doesn't belong there. It doesn't serve the purpose.
I'm saying it. The paralleling aspect of it, just let 250.122 be the guide when it comes to sizing your equipment ground. And if you're already going to require them to be full size in each raceway, then why even address it here? Although I will say that I've submitted some cleanup that I think will clean this up, and hopefully the code panel will listen. And I'm more than happy to come in and talk to them since I don't know if we'll be in person or not, or we're going to be this COVID thing. I don't know. I don't know how that's going to be.
It might be in a Zoom meeting.
There probably are going to be in those type of meetings coming up. Now, you had a question or something before I?
Well, there's a couple of these. So did you want to wrap up what you're going to, and then I can ask a couple of these questions if we have time to get to them? Or
yes.
Okay.
So let me just finish 310.10G3, separate cables or raceways. It says we're running separate cables or raceways. All right, and the reason I got to say this is because you could have parallels in one raceway. And if you had parallels in one raceway, then you would only have one equipment ground in that raceway, whatever the size of the overcurrent device is. Okay? So code allows you to have one raceway. I could have multiple sets in there if it was smaller conductors, not smaller than 1 aught. But if I had a trade size 6, for example, rigid, I could have a fair amount, provided it don't exceed the fill requirements. But then I would only have one equipment ground in there. And again, it's still going to be sized based on whatever the overcurrent device is, right? So I could have that, or I could have multiple raceways. So what it says here in 310.10G3 is if I have separate cables or raceways, it says we're running separate cables or raceway. The cable or raceways with conductors shall have the same number of conductors and shall have the same electrical characteristics. And this is reminding us that the cables or the actual raceways also have to have the same characteristics. And that is, if you're running all of them in one raceway, it's got to be a certain type of raceway versus, all metal raceway, for example. It says conductors of one phase, polarity, neutral, grounded conductor, or equipment grounding conductor shall not be required to have the same physical characteristics as those of another phase, polarity, neutral, grounded conductor, or equipment ground. And again, that's just to remind you that where I had them in multiple raceways, that I could have phase A could be copper, phase B could be aluminum, phase C could be copper-clad aluminum. Boo. But it could be. And so, so again, I could have the different types of characteristics, but only they have to be similar for the same phase. So all the A's have to be the same. All the B's have to be the same. All the C's have to be the same. That's basically what it's alluding to when we run it. So it first starts out by assuming they're all in one raceway. And that's where all these rules match up. And then again, the lengths are not a problem if they're all in the same raceway. That's a no-brainer. It only becomes an additional problem when you have multiple raceways like we talked about, which you could have different lengths. But you're going to have to make up that distance, and you're not going to be able to just cut it off. You got to keep the lengths the same, those type of things. All right? All right, now, that's pretty much all I'll cover on that before I jump into 251.22 if we even got time. So give me what some of your questions.
Yep. So let's see here. Is it Moses? He was asking. He wants to know the raceway size for each parallel with the equipment grounding conductor at the 250 kc mill. That's something we'd have to look into.
Yeah, we're not going to.
And we'll get back to you on that.
Size it. We would have to size it. So again, Moses, you're wanting to know. Obviously, your question is you're wanting to know how to do raceway fill. I have a video on that explains that on my YouTube channel that talks you through how to do raceway fill using Chapter 9, Table 4, and Table 5, and it will talk to you all the way through how to do a raceway fill calculation. So we're not gonna do that one in this episode.
Are there any raceway limitations that you can use? Can you do it in PVC or ENT? Pretty much, is there any leeway if you're using PVC rather than EMT? And what's the most common one that you see underground? I used to always see PVC.
All right,
a lot of times.
So here's what I wanted to bring back to. So you've got your code book, and this is going to also tie back to Joel's thing. What I wanted you to do is give a look at 300.3B1, okay? And it's kind of, we'll tie this up a little bit.
Sure.
Now, here's what it says for those that are following along. It says parallel installations. It says conductors shall be permitted to be run in parallel in accordance with the provisions of 310.10G, which is kind of what we just kind of went over, right, Jay? It says the requirements to run all circuit conductors within the same raceway, auxiliary gutter, cable tray, trench, cable, or cord shall apply separately to each portion of the parallel installation. In other words, you treat each phase separately, phase A's, phase B's, phase C's, equipment grounds, whatnot, each one treated separately. Notice it says, and the equipment grounding conductor shall comply with 250.122. 122 is going to tell you the equipment ground has to be full size in all raceways. Yes. It will also tell you that it never has to be larger than the largest ungrounded conductor. Okay? All right? So it will give you all that. Next, it says connections, taps, and extensions made from parallel conductors, and this kind of addresses your question early on, Jay, shall connect to the conductor of the parallel set, grounded and ungrounded, as applicable. Parallel runs of cable trays shall comply with 392.20c. So you can tap, for example, parallel sets. But when you tap them, you're going to tap those in parallel as well. So whatever your need is, you're going to make sure you evenly tap those out if you need it. Not really the subject to tonight, because that just goes into when you might tap conductors, because you can tap feeders. Just because they're running parallel doesn't mean you can't tap feeders. But you just can't selectively tap. You know what I mean? You've got to tap follow proper tap rules, 240.21. But here's what I wanted to get to. Look at the exception. The exception says conductors installed in non-metallic raceways run underground, so this is for Joel, shall be permitted to be arranged as isolated phase. That means all A's in one, all B's in the other one, and all C's in another. So it allows that installation, non-metallic raceways, kind of what I didn't want to go into, Joel. You heard me say I didn't want to talk about it, but it was non-metallic, and it was underground. But this is what it is. You're allowed to do that. It says the raceways shall be installed in close proximity, and the isolated phase, neutral, and grounded conductors shall comply with 300.20b. And that is an inductive heating rule. Okay, that means you have to follow those rules. So if you want to do it, Joel, and you want to run all A's in one, all B's in one, and all C's in another one, and neutrals in a different one, if you want to do that, you can. But it has to be what? Non-metallic raceways, underground. Now, because you separated them like that, you're going to create a potential for inductive heating when it comes to something like a sidewall of a ferrous metal enclosure. And most of them are ferrous metal. Aluminum's non-ferrous. So, again, if it's aluminum sidewall, you're okay. But if it's a ferrous enclosure, then you got to be careful. And it's going to direct you to 300.20b. Now, take a look at that, Jay. 300.20b. That's dealing with the individual conductors where they come out, pass through the metal. You create what's called a magnetic property that can cause heat. And it can cause that PVC to melt down. It can cause that insulation to melt down. So it gives you some rules. Now, when I've had people do this and they want to do it underground and they come up into the bottom, usually it comes up in the bottom of an open bottom gear, for example, if they want to do that. So there is no sidewall, right? They just open bottom. But if they do come up out of the ground into a piece of equipment and it goes into the sidewall and it happens to be a metal enclosure like a steel cabinet, then you're going to drill your holes and then you're going to cut a slot between each of the knockouts. And what it's doing is replicating one big hole. Even though it's 5 holes or 4 holes, by cutting that notch between them, it actually acts like one big hole. And then you have less of inductive heating. And so that's going to give you one of the rays. Or you could take the entry and you could change it to a non-ferrous entry. So some of them, you would cut it and you would actually have an aluminum panel or a non-metallic panel that those raceways would connect to, so that they don't connect to a ferrous metal enclosure. Because that's where you have the problem, because the ferrous metal creates the heating effect. Okay, and it could damage the conductors. So as long as you follow the rules that are in 300.20b, Joel, and as long as your installation is underground and it's non-metallic, then there is a rule that allows all the A's to be in one raceway, all the B's. It's just not practical. And in all my career, most of my paralleling took place above ground in buildings, feeding other switchgear and other pieces of equipment. So it wouldn't even come into play. So at that point, you're forced to have ABC in one raceway, ABC in another raceway, ABC in another. But again, it's good, Joel. I mean, I didn't want to go there tonight, but I wanted to venture back because I felt like Joel needed an answer. And there is allowance for you to be able to do that. But it is, again, very specific, underground, non-metallic, and you got to make sure that you follow the rules and 300.20b, or you're going to really cause a problem in your installation. Okay?
Yep.
Hopefully that answered for Joel. What other questions did we have tonight?
Well, Elwood had a quick one. He says the PVC, do you see it more commonly, PVC or EMT? I would say a lot of times we use PVC, but you have to go back to the electrical drawings as well and make sure that they're not requiring you to do it in EMT, because I've had some projects where they require you to do all EMT throughout the whole project. Mm-hmm. And again, you can do an RFI and see if you can get that changed. So typically I've ran underground parallel conductors and PVC. Caleb, can you derate the grounds the same as the neutrals? No, you can't.
Full size.
We went over that.
In order to also cover that real quick, because I was a little late earlier with getting the stream right, so I'll take the liberty of stretching this out so that me and Jay can listen to ourselves talk some more. We'll go down, and I want to show you 250.122. So, Jay, if you got your code book, you can go to 250.122. And I'm just scrolling along for people that are watching on the screen. They're saying, why don't you use the search feature? Because I'm not. Here's 250.122. All right. Okay, so the general requirements. And you see increase for size. Then you got multi-circuit in general and everything like that. What we want to look at is when you talk about 250.122F, where it says conductors in parallel. Because remember, that's what we're talking about, right?
Yep.
So let's kind of look at conductors in parallel a little bit. So here's what it says. You see a lot of gray. For those that are following the code book, you see there's an awful lot of gray because we did make quite a few changes. But what we want to talk about more is looking at it here. So the very first one, 250.122F1. You'll notice that, first before that, look at 250.122F. It says, for circuits of parallel conductors as permitted in 310.10G, the equipment grounding conductor shall be installed in accordance with 250.122F1 or F2. So what happens is you've got all these other rules in 250.122, but when you're dealing in parallel, it's directing you to follow F1 or F2. It's telling you, you're now in F1 or F2. This is where you are. You're no longer in 250.122 A, B, C, D, E. You're right here for all intents and purposes. It says, A, if this is just one raceway and you're putting, let's say I have 3 sets and they're only 1/0, right? So I say if trade size 4, I could have 3 sets of 3 blacks, 3 blues, 3 reds, and 3 neutrals, and 1 equipment ground fully sized in one raceway. They're parallel, but they're in one raceway. Okay, as long as I didn't exceed the raceway fill, Chapter 9, Table 1. Okay, I didn't exceed 40%. Okay, so as long as I didn't exceed it, right, then I'm okay. Mm-hmm. Assume that I'm okay. It says, single raceways or cable trays, auxiliary gutters, or cable tray, if circuit conductors are connected in parallel in the same raceway, and we'll skip all the gutter and tray, whatever. It says a single wire-type conductor shall be permitted as an equipment grounding conductor. So that means I can have 3 sets, but I only have to run 1 equipment ground. Right. Because once they get to the other end, they're all going to go. All the blacks are going to go to one terminal. All the reds are going to go to a different terminal. All the blue, so it's still parallel, but it's just still, all good. So I can run 1 equipment grounding conductor, and I'm perfectly fine. It says the wire type equipment grounding conductor shall be sized in accordance with 250.122 based on the overcurrent protected device for the feeder or branch circuit. So it gives us the reference to 250.122, which ultimately is going to send us to the table based on the size of the overcurrent protected device. Right? Yep. Now, what I would like to see them actually is, the reason they don't send you directly to the table, people ask, because you still have the rules that say that, well, now this is a good one to bring up right here. I want to make this real clear, Jay, to people, because this is where people get confused. It sends me to 250.122. 122 says, now watch this, right here. It says, copper, aluminum, or copper-clad aluminum equipment grounding conductors of the wire type shall not be smaller than shown in table 250.122. It says, the equipment grounding conductor shall not be required to be larger than the circuit conductors supplying the equipment. Okay. Let's explain something real quick. This is where people really, I'm going to blow people's minds here. You ready? If I was only running a single conductor and my single conductor was 1/0, then in theory, my equipment ground would never have to be larger than a 1/0. Make sense? It says right there that it never has to be larger than the ungrounded conductor. Okay. Yep. When I'm doing parallels and it says that, it means that my equipment grounded conductor never has to be larger than the parallel sets are acting as a single conductor. So if I had 3 250s and they were running them in parallel, then my equipment grounded conductor never has to be larger than 750 kc mil because they're acting like a single conductor. They're being run in parallel to act like a single conductor. Now, this is where I think this has to be cleaned up. And again, I've got public inputs to clean this up. Because some people say, no, it doesn't have to be larger than any one of the phase conductors. No, but the phase conductors are being run in parallel to achieve a certain ampacity. So they're running parallel, but they're trying to act as a single conductor, right? Because we're trying to get all that ampacity for it. So when it tells me that it never has to be larger when you're running parallels, basically it's telling me it never has to be larger than the parallel conductors combined. That would be the equivalent of a conductor. It's the same thing that we do when we go and do those tables, for sizing the grounding electroconductors, or when we're sizing the grounded conductor under 250-102C1. Remember when it says the largest ungrounded conductor or a parallel equivalent? It's the same concept. That's the same concept. So we've got to clean this up. But anyway, that's not for y'all. It's either I'm off in left field, and you might say I am, and you might say that I'm one of these. Hold on, where is it? Where's my button, Jay? But I have some pretty high friends in high places who say, Paul, you're absolutely right. We got to change that. All right, so now let's talk about the one that we're dealing with, multiple raceways. It says, if conductors are installed in multiple raceways and are connected in parallel, means they're connected at both ends like they're supposed to be, a wire-type equipment grounding conductor, if used, because, again, you could just use the EMT. You could just use the rigid and not run an equipment ground anyway, right? Sure. But most engineers are going to make you run one, so, okay.
That's right. And
I work for a wire company, so run that wire. Make Paul's paycheck. All right, so again, I lost where I was. So a wire-type equipment grounding conductor, if used, shall be installed in each raceway. Okay, so it's in each raceway and shall be connected in parallel. So what that means is each one of them has to be in each raceway, and that ensures me that they're each going to be in parallel, although we're not using them for a parallel application to get more current. I mean, they're equipment grounds. So this is part of the language that has to also be changed. But I'm okay with it because they're still technically in parallel. Okay? And it's not telling me how they have to be connected. They still got to be connected to the metal enclosure at each end, right? So, I mean, they're still got to be connected, so that doesn't hurt me. All right? Now, it says, the equipment grounded conductors installed in each raceway shall be sized in accordance with 250.122 based on the rating of the overcurrent protective device for the feeder or branch circuit. Okay. So, if it's a 2,000 amp switchgear, and I'm running parallel sets in multiple raceways, Jay, and it says that I have to have an equipment ground in each raceway, and it's telling me that each raceway, they have to be sized based on 250.122, based on the overcurrent device, then it has to be full size at each raceway, right?
Right.
So what some people will say is, okay, Paul, okay, smarty pants, Abernathy, so if it's 5 sets of 600 kc mil, my equipment ground for 2,000 amp, my equipment ground would be, I think it was 250 kc mil. I think that's what it says in 250.122. 250. Yep. So I'd have a 250 kc mil in there in each raceway with a 600. So somebody said to me one time, they said, what if I increase the size of the conductors because of voltage drop, and 122B tells me that I have to increase the size of the equipment grounding conductor proportional? Okay. They said, well, in theory, Paul, what if the conductors were increased in such a size that the equipment grounding conductor ended up being larger than the 600 kc mils in each raceway? Is it required to be larger than the 600, or because it doesn't have to be larger, than the largest ungrounded conductor in that raceway, that it doesn't ever have to be larger than a 600 kc mill. My response to that is it has to be sized. It can be larger because it doesn't have to be larger than the multiple sets that are making up that phase. So if there is 5 sets of 600s, then to be honest with you, it would be 600. What is it? 600,000 times 5. That's 3 million. Okay, circular mills, KC mills. Then my equipment grounded conductor never has to be larger than 3 million circular mills. Okay, so that's where me and many people differ. They say, no, it never has to be larger than the 600 if that's the largest ungrounded conductor that's in there. I happen to disagree, and some pretty high up people agree with me. And so at the end of the day, probably a moot point, Jay, right? Because if it's 5 sets of 600s, the equipment ground's only got to be, it's a 250.
Yeah.
It's going to be 250. But what I was trying to do is explain to people that even though it says go back and look at 250.122, when it says back in 250.122 in A that it never has to be larger than the largest ungrounded conductor, that was for when you're dealing with a single equipment grounded conductor in a single conductor application. If it's run in parallel, you treat that phase in cumulative fashion. If I have 5 A's, 5 B's, 5 C's, then the actual largest conductor is the combination of all of the phase A's. Okay?
Sure.
Because we have to remember, though, we're only sizing the equipment grounded conductor based on the overcurrent protected device. Okay?
That's
so
right.
hopefully we're going to clear that up in the 2023 and make it, because once you get into F, you're locked into F. So there's some things that I have proposed that will clear this up. And what it's going to do is going to make the code panel, I'm on that panel, it's going to make them have to give us an answer because I gave them 2 proposals. One my way and one reverting it the other way. So I'm going to make them battle themselves at the code table because I'm giving them 2 proposals. And I want to find out what they really mean because there's a few people that say never has to be larger than the largest ungrounded conductor in that raceway. Okay. I don't know where it says that, but okay. And what they mean by that is because they go back when it says to go per 251.22, they go back to right here. And they go to this line where it says the equipment grounded conductor shall not be required to be larger than the circuit conductors supplying the equipment. However, this is where I come in. So, Jay, if I have 5 sets of 600 kc mills, and I'm supplying that piece of equipment, what is the size of the circuit conductors that are supplying that equipment? It's 5 sets. It's 5 of the A's added together. It's not the individual conductor in each individual raceway. It doesn't say that way. So we're going to get clarity to that. And hopefully I didn't totally confuse people tonight. Tell me I didn't confuse you, Jay.
No,
okay.
No, not at all.
Good.
It was good.
All right. So anyway, that's just do we have any other questions?
Let's see. Can you derate?
Because I don't have access to the questions. Now I do because we're back on the questions here.
So, Moses, do I have to do adjustment for bundling of conductors in a parallel set if I only have A, B, C, and a neutral?
Yeah, so when it comes to the number of current carrying conductors in a raceway, so if I'm going to apply adjustment and corrections in the 2020 code, that is 310.15B and 310.15C. That's the new adjustment and corrections that changed. It used to be 310.15B2A, 310.15B3A, but now it's 310.15B and 310.15C. Same thing. So when you're dealing with the number of current carrying conductors, you're dealing with C. And when you have an A, B, C, and a neutral, I only have A, B, and C are the current carrying conductors. The neutral may or may not be a current carrying conductor. Depends. If it's a 3-phase, 4-wire Y system, and they have high harmonics, or more than 50% of harmonic loads or nonlinear loads in that building, like a lot of computers, a lot of electronic ballast lighting, a lot of variable frequency drives, all this kind of stuff that really chop up the waveform, then guess what? That neutral might be considered a current carrying conductor. And if that's the case, you've got 4. Yes, you're going to have to do an adjustment for that. Okay? So I should say actually a correction for that. You're going to have to do a correction. Adjustments, ampacities for temperature. Corrections are for current carrying conductors. Just remember, C for C, current carrying conductors. So, yes, you're going to. Now, in the reality of the world, will it make that much of a difference? Probably not. It's 80%, I think. So, I mean, might
Plus
not.
You're using the highest chart.
Yeah. Plus, I'm going to use the highest ampacity.
90 degree.
Yeah. So we use 420, whatever it was for the 75. You're obviously going to use the 90 for adjustment and corrections. Okay. Again, as long as after you do your adjustment corrections, you still have a conductor that can handle the load. Okay. And that's important. So I always tell people for adjustment and corrections, pick your right size under the terminal limitations. Pick the conductor you need to use first under the 75, if that's what your terminals are rated for. And then make sure that the conductor's okay by using the 90 for adjustment and correction. But always start out by picking the right size you need based on your terminals. Then the only reason you're using the 90 is to make sure that, do I still have a conductor that can handle my load afterwards? Yes. Okay, I'm good. So I tell people adjustment and corrections for ampacity, just make it simple. Choose the conductor you need based on the terminals, 110.14c, it's 75 degree rated terminals. Pick your ampacity for 75, then look at your adjustment and corrections, and then use the 90 and see if after you do that, you still have a conductor that's okay. Then you're okay. So always start out by picking your conductor first based on your terminals, and then comparing it to the 90 degree and see if you're okay. So any other questions? Don't have any more questions on that?
No, Elwood said thanks. No problem.
Cool. So I tell you, paralleling, summarize it, Jay. Conductors, A, B, C, let's say, if you're doing 3-phase, A, B, C, and neutral and equipment ground in each raceway. And you want to make sure that they're the same length per phase. Yep. You want to make sure the same characteristics, same type of insulation per phase. Same type of raceway per phase. Okay, for sets. Okay, so again, you want to keep your raceways consistent. What else? Lengths. What else do we? Lengths. Characteristics. What else do we got? What else did I miss here? Oh, circular mills. Again, you could have phase A be one size, phase B be a different conductor type and be a different circular mill. Obviously, if it's aluminum, it'd be different. And then C could be a different. But you have to keep all of your phases the same. Right? Make sense?
Yep.
I can hear people now. I can hear the emails now, Jay, about my theory on equipment grounding conductors and them saying, no, it never has to be larger than. I'm like, stop and think for a second. Do I want to go back there again, Jay? No, I don't want to go back there. Anyway, never mind.
So here's and then 4 under again under 310.10 G2 is have the same insulation type. We've kind of went over that, and then 5 would be terminated in the same manner.
Yeah, so again, like we said, terminating in the same manner means terminating the same type of lug, so that the characteristics in one is not different than in the other. Okay? Anything that deviates from it, I mean, obviously, if I've got same length and everything, but I change the length, then I change the amount of resistance in the conductor, or in our case, AC, so change the impedance. Okay? And so when you're thinking about current, it's not going to divide evenly. So one conductor is going to have more current on it than another. So they have to be the same length. Probably less important about the insulation type. Probably it's not going to make that much of a difference. Obviously, the circular mills have to be the same, or it wouldn't evenly distribute out. terminate in the same manner just really means lugs. All of them are in the same type of lug. I think the confusion is it doesn't mean they all have to be, I don't know how to say it. They all have to be identical types of lugs, okay? But typically they're going to be on a bus, and then all the lugs are going to be on the bus, and you're just going to terminate them all the same way. It's typically. Again, the only time that I deviate from this is equipment grounds, is I fail to see the point that they need to come all together on the same lug because they're not being utilized in a parallel application. Again, some people argue it says it here because it's in there, but I will argue that I really think that it's pointless to do it. If you want to do it, fine. It's obviously not going to hurt anything. But when I say terminate in the same manner, it doesn't say at the same location. So for me, if it's a metal enclosure and it's bonded, and I bought 4 of them to lugs that were on the equipment ground bus, but that bus is bonded to the metal enclosure, and I take the other equipment ground, the last one, maybe, it was the same length, met everything, but I wanted to take that to a lug that I drill and tapped into the enclosure, and I used a 250.8 termination compliant. Is it going to make a difference? Jay, is it going to make a difference? It's not.
No,
it's
not at all.
It's an equipment grounding conductor.
That's right.
It's not being utilized in a parallel. Current's not dividing on the equipment ground. If that was the case, why would we have to make it full size in all raceways? If we can parallel the phase conductors, if we can parallel the neutral conductors, but we can't parallel the equipment grounding conductor because we want it to be full size, then guess what? Why should it have to terminate in the same position and treat it just like the others? It's foolish. Now, people are going to say, but that's because that's what the code says. Well, I'm going to argue that it says terminate in the same manner just means the same type of lug, but it doesn't have to be in the same location. That's how that's how I consider it. You can agree to disagree. But I will also remind you that the general rules of paralleling, the general rules now, which is 310.10G1, doesn't make any mention of an equipment grounding conductor in there. It only rears its head under the characteristics in item number 2. Okay? That's where it rears its head. And I'll also remind you, 310.10G1 references you to G2 through G6, where it talks about these different things. The general rule doesn't say anything about an equipment grounding conductor. Okay? So, do we got to clean that up maybe? Somebody will tackle that. Maybe that doesn't need to be fixed, Jay. Maybe I'm just too much wine during the day. I don't know. Could be. All right. Well, I think that that's probably all the damage that we could do today, Jay.
Yeah, I think Joel said he's doing a new build or a underground ground up. So with this video, Joel, you should be telling your project manager, your foreman, how to do parallel run. So, yep,
parallels, baby. All right. Well, Jay, is anything else? Do we? I don't know. Today's episode, I don't know that I would have gotten you a sponsor from Milwaukee. I don't think we would have gotten that tonight, Jay.
No.
Maybe next.
No.
Maybe Ryobi, maybe.
Yeah, that could be. We could get a sponsor for Encore from Encore, maybe. Wiring.
Hold on. I got something for that one. Hold on.
Oh.
That's crickets. That's exactly what I'd hear. That's exactly what I'd hear if I asked for it. Anyway, Jay, it's a great show tonight. Covered some topics. So I guess that's it for tonight. We will see you next week at 8 p.m. We'll have some interesting topics. Go to electricianlive.com and you will see what next week's topic will be about. Usually I will post it the first of the week, so I'm sure it hadn't been updated because it might have been to be determined, but we will keep you updated. I want to thank you again. Joe, say good night to everybody.
Yep. We'll see you guys. Thanks for joining us. See you next week.
All right, guys. Take care. Until next time, stay safe.
You're listening to Electrician Live with your host, Paul Abernathy and Jay Grunberg.